Imagine that you have an equilateral triangle. Split each of the sides into thirds and draw another equilateral triangle on the middle segment. Now do the same thing again. What if you do this over and over again? Well, you get a fractal. In fact, this is a famous fractal called Coke snowflake. Fractals, like Coke snowflake, are made up of repeating patterns at different scales. So no matter if you look far away or up close, the fractal will look the same. In other words, the smaller parts of the fractal resemble the larger parts of the fractal. One puzzling thing about Coke snowflake is that if you continue doing the procedure, the area of the fractal is finite, but the perimeter is infinite. Weird, right? In fact, mathematicians were highly puzzled by fractals until 1975, when a mathematician named Mandelbrot started studying fractal geometry. He came up with the equation z is equal to z squared plus c. Here, z is an imaginary number in the form of a plus bi and c is a constant. Mandelbrot tried out different constants for c and found all of the possible solutions for z. He called each of these sets of numbers a Julia set. He graphed all of these solutions on a grid. The a value told him whether to go right or left, and the b value told him whether to go up or down. So the a value kind of acted as the x-coordinate, and the b value acted as the y-coordinate. And here are some examples of Julia sets he created. He decided to combine all of the Julia sets to create the Mandelbrot set. He graphed this set and came up with the Mandelbrot fractal, possibly the most famous fractal today. Today, we use fractals all the time. Fractals have allowed us to understand important scientific concepts, like how bacteria grows, to patterns that water forms when it freezes. We use fractals today in wireless cell phone antennas. Remember how I said that the Coke snowflake has infinite perimeter but finite area? Well, scientists exploited this idea and created a compact antenna that can pick up a lot of different signals because of its large perimeter. Fractals are everywhere in nature, from broccoli to rivers to even our cells. The blood vessels in our lungs are a perfect example of fractals. So I encourage you to go out and find some fractals yourself, or even create your own.